So today we're going to look at doing a one sample t-test using PSPP. So just to introduce it to this data set. So this data set has two groups. So we have a rehab group and a control group. So it's about patients who had ankle injuries and they took their lower extremity functional scale score before and after intervention. But the intervention was only for those who were in the rehab group. So basically, the lower extremity functional scale score pre is the measurements before, and the lower extremity functional scale scores underscore post is those scores taken after a period of time. So for example, someone should ask, or someone should make a statement to say, on average, when patients have ankle injuries, their mean lower extremity functional scale score is 20. And you want to use your data to test that claim, to see if it's a claim you should support or if it's a claim that you feel to reject. But before we do a one sample t-test, we have to ensure that we meet the requirements, or our data set meets the requirements for that test. So what are the requirements? So when doing a one sample t-test, you have to ensure that your sample is a simple random sample, and either of the other two requirements, either one of them or both of them. So the population that you took the data from must be normally distributed. If not, at least the sample size that you're using should be greater than 30 so that you could apply the central limit theorem. And that's something that we'd have to discuss in a different forum. But once you're accustomed to doing statistics, or you have done statistics, you should have an idea of why the central limit theorem is so important to these statistical analyses. So back to our data set. So let's use the low extremity functional scale scores before the intervention. So this would be when the patients now come in and you measure. So let's test this claim to see if on average these patients, their score is about 20. So we'll go to analyze, and because we are comparing means, we'll go to compare means, and we're doing a one sample t-test, so we'll go to one sample t-test. So here we have things set up already. So the low extremity functional scale score will come under here where you have a test variable, and the test value that we're doing is 20, so you would enter 20 there. Okay, I will click OK, and then when we click OK, if we look here and we look closely, we see in here for the sample data, the mean is 20.36 and a standard deviation of 12.16. So we'll look at the results of the test. It produced a t-value of 0.43 and the significance value associated with this in the two-tail. And it's important for you to notice that when you get an output from PSPP, it will give you the p-value for the two-tail. So if a test is a one-tail test, you'll have to use that t-value to find the p-value in the respective tails separately. But just remember that you get a two-tail p-value. And if you look at this, it's 0.667, which you know is larger than our benchmark of 0.05. So with this now, we'll fail to reject the null hypothesis that indicates that on average, the lower extremity functional scale score would be 20. And here we have what we call the mean difference, which is 0.36, which is really small. And we look at a 95% confidence interval of that mean difference. So here in the lower end we have a negative value, and in the upper end we have a positive value, which means that this confidence interval includes 0. So that also tells that there's a possibility that, 20 could actually be it, because it might not be different from what the test data or the sample data is showing. So that is how you do a one sample t-test using PSPP.